I'm making a video for you to have some notes to help you when you're studying for taking your Chapter 7 test in statistics. So in question number 1, there's 261 accurate orders and 73 that were not accurate. So you're going to click on Question Help and open the StatCrunch program, and then you're going to go to Stats, Proportion Stats, One Sample with Summary, and then you're going to look at those numbers. Okay, so you're wanting to make a confidence interval of the percent of orders that are not accurate. So this means that the ones that are not accurate are counted as successes. So there's 73 successes in this sample, 73. Now normally you don't think of a not accurate order as being a success, but when you're trying to create an estimate of that, you have to classify the ones that are not accurate as the successes. So there's 73 successes. Now the total number of observations is the total number of orders altogether. So if you take 261 plus 73, 261 plus 73, you get 4, 6 plus 7 is 13, and then 3, so you get 334. 334 observations. And now you want to click on confidence interval, so you choose that option. And you want to make it be 95% confidence. So this is good, 95% confidence. And then you want to click compute. And then this is your result. So the confidence interval goes from a lower value of that to a upper value of that, and then round it off to 3 decimal places. So 0.174, and then 0.263. And then let's see. In part B it says compare the results from this part to the 95% confidence interval that are not accurate at a different restaurant, restaurant B. That goes from 0.201 to 0.282. So that's about 20%, which is right in between the middle of this. So this interval and this interval, they overlap each other. And when they overlap each other, that means neither restaurant appears to have a significantly different percentage of orders that are not accurate, since they overlap. All right. Now let's look at question 2. So in question 2, we want to, there's a formula that you can use. So the sample size needed is equal to PQ multiplied by Z over M squared. And so the sample size needed is equal to, if you don't know anything about the percentage to be estimated, then you assume that P and Q are both equal to 0.5, like that. So P and Q are both equal to 0.5, you assume. If you don't know anything about it, you just assume that. And then the Z value for a 99% confidence level, I believe, is 2.576. But let me just look that up real quick just to make sure. So stats, calculators, normal calculator, and then click between. Then you want to have 0.99, then click compute. Yes, so the z value is actually 2.5758, or about 2.576 for 99%. So you would use this number right here for this value, and then for the margin of error you would use a 0.02 margin of error. So if I do that with a calculator real quick, I would get 0.5 times 0.5 times parentheses 2.5758 divided by 0.02 squared, and then I round that up, so 4146 would round up to 4147. Okay, now there's actually a more easy way to do it. So you simply click back in StatCrunch, and I would recommend that you use this way instead of the formula to make sure you get your answer accurate without any mistakes on your test. So you just close that, and then you go to stats, proportion stats, one sample, width and sample size, and then now you go look back at the problem. You want to have a 99% confidence level, so change that to 0.99. And if you don't know anything about your target population, then you assume it's a 50-50 chance, so you will assume that it's 0.5 for your target proportion. And then for the width, a margin of error 2%, there's a right side and a left side, so you double that to get the total width. So if you double 0.02, you get 0.04. And then you click compute, and then you get the sample size 4147 directly from there. So remember, we got 4146 rounds off to 4147 by doing it by hand, and then we also got 4147 by using the width sample size calculator in StatCrunch as well. So the correct answer is 4147. Now it says, assume that prior studies have shown that about 55% of full-time students earn bachelor's degrees in 4 years or less. So that means you're going to assume that instead of assuming that it's 50-50, you're going to assume that it's 55 who do it, and then therefore that means 45% who don't do it. So 55 and 45, and that adds a decimal. Those are 0.55 and 0.45, and then multiplied by the same thing, 2.5758 divided by 0.02 squared, and this time you'll get a sample size of 4106 if you round it up. But of course, the easier way for you to do it without as many mistakes is just change your target proportion right here to be 0.55. Then click compute, and you still get 4106, the exact same number. And then it says, does the added knowledge in part B have much of an effect on the sample size? Well, it's made it a little tiny bit smaller. Does it have much of an effect? So I would say no, using the survey information only slightly reduces the sample size. Okay, so no, it only slightly reduces the sample size. Now if the prior studies had shown that the percentage of full-time students was a lot bigger than 50%, like let's say 80%, or a lot smaller than 50%, let's say like 20%, then it is likely that the sample size would have been a lot smaller. And in that case, the answer would have been yes, it does reduce the sample size a lot. So depending on what your problem is, the random numbers in your problem could be different than 55, and so your problem might possibly be not quite the same answer as the example problem that I'm doing, which is also a random problem. So does the added knowledge have much of an effect? In my problem, the answer is no. It only slightly reduces the sample size. Okay, then Let's look at question number 3. So it says, what is the confidence interval estimate of the population mean? So we have a sample of information. We're trying to estimate the mean. So we'll click on this data icon and choose Open in StatCrunch. And there's the data set in StatCrunch. And you're going to do a t distribution. So you're going to do, click on the Stat button, click on T-Stats, click One Sample. We have data this time instead of just information, so we're going to click on Data, and then select Mercury, and then it wants it to be a 95% confidence interval. So we're going to choose that, and it already says 95, so that's good. And then click Compute. So the confidence interval result is a lower limit of that and an upper limit of that. So if I round them off to 3 decimal places, it would be 0.377 and then 1.086. Yes, that's correct. Okay, now, does it appear that there's too much mercury in the tuna? Well, it is possible that the mean might be more than 1 part per million, which would be too much mercury. So also, at least one of the sample values does exceed, like the 1.36 is definitely more than 1 part per million. So even in your sample, there's at least one that is in the sample that exceeds 1 part per million. So that means at least some of the fish have too much mercury. So let's see. So I would say yes, it could be that there's too much mercury in the fish. It is possible it's greater than 1. And also at least one of the sample values does exceed 1 part per million. So at least some fish have too much mercury. So I would go with those 2 answers. Okay, now, so here are some data. Let's open them up in StatCrunch, both of them. Okay, so we're going to look at the instructions. It says construct a 95% confidence interval of the main drive-through service times at dinner for restaurant X. So when you're constructing an interval from a sample of the main, you're going to use the t distribution. So stats, t-stats, one sample with data. I'm going to click restaurant X, and we want to interval the main drive-through times. So we're going to do 95%, which it already has. So I'm going to click compute, and the result, oh, sorry, forgot to check on those. So if you do something wrong, you can click on options and edit. It'll just take you back. So I forgot to do something. I did click on restaurant X, so it says restaurant X. What I forgot to do is I forgot to click on confidence interval. So I need to click that. And then it's 95%, so that's already set to 95%. Then click compute. And then this is the result. So the lower limit is there. The upper limit of the confidence interval is there. So round it off to 1 decimal place. So 0.3, and this one needs to be rounded up. So the 0.8 needs to be rounded up to 0.9. So this dinner service, drive-through service times at dinner are between 161.3 seconds on average and 196.9 seconds on average. So that's the confidence interval for the average or the main drive-through service times. Then let's do the same thing for dinner at restaurant Y. So just change the options, choose restaurant Y instead of restaurant X. Then it already has confidence interval selected, so click compute. And then this time the answer is 139.17. And the upper limit is 167, so round it off to 1. So the 0.1 rounds up to 0.2, and the 0.3 stays the same. And then now let's look at the next part. So this interval overlaps the bottom side of this interval. So let's look. The confidence interval estimates, they do overlap. So it has to be B or D. And so if they overlap, then there does not appear to be a significant difference between the mean dinner times at the two restaurants. So there we go. That's the end of that one. Then problem 5. Okay, now actually there's a small mistake in this tip. So you can just ignore that. I'll show you what to do. That is a helpful tip though, but you can just ignore that because I'm showing you what to do that's even better. So let's just see. Okay. So click on StatCrunch again. Actually, I forgot it's already open, so you can go back to the StatCrunch window that you already have open if you want to, and then you can click Stats, Z-Stats, one sample, then with sample size. So let's see. So an IQ test is designed so that the mean is 100 and the standard deviation is 12. And so when the standard deviation is known to be sure, like it's 12, then that means you're going to use a Z distribution. So find the sample size necessary to estimate. Okay, so let's go ahead and do this in, let's say, 99% confidence level. So we're going to type that in right here, 0.99. And the standard deviation, it says, is 12. And we want to estimate the mean IQ score so that it's within 3 possible points. So it could be 3 points too high or 3 points too low. So that's a total width of 6 points. So the width is going to be 6 points. And then determine the required sample size using technology, which is what I'm showing you right here. So the required sample size is 107. So once again, what I did is I went to the Stats button, which is behind this window, and I clicked on Z-Stats, one sample, and then I clicked on the very last option, with sample size. And then I entered the confidence level, 99% is 0.99. The given standard deviation of the population, 12. Then the width I entered 6, and then I clicked compute. And it automatically rounded the width down a little bit, but the sample size is what I'm looking for, so 107. So that's perfect. Okay, and then it says, would it be reasonable to sample this number of students? I would say yes, that's not too big. So would it be reasonable? Yes, that's a fairly small, yes, that's a fairly small number, which is reasonable, I would say. Now, a big number would be like if you had to sample 10,000 students or something. So I'd say yes, it's reasonable. It's a fairly small number as things go. Okay, so perfect. Now, in question 6, so it says find the sample size using the range rule of thumb to estimate the standard deviation. So remember, a range rule of thumb means you take the range divided by 4 to get the standard deviation. And now that's not, of course, that's not the exact standard deviation. That's just an estimate, just kind of like based on a rule of thumb. So it's not really a precise mathematical value. And if your data are not distributed like data normally are, then that is not going to work. But we'll use that though. So the range is equal to a high of 117 minus a low of 41. So the range is 76. And then 76 divided by 4 is exactly 19. So based on that rule of thumb, the range divided by 4 is approximately the standard deviation. So we'll just get 19. Okay, perfect. Well, now we are going to do the same thing. So let's see, find the minimal. Okay, so go back to the same thing again, and we're going to do a 90% confidence. So 90% confidence, and that the sample mean is within 4. Okay, now let's see. And I'm assuming that remember, I'm assuming the standard deviation is 19 because of the range rule of thumb. Standard deviation equals 19. And then the width I want is within 4, so it could be plus or minus 4, so that's a total of 8. So the width is 8. And then the sample size I need is 62. Okay, now we're going to assume that the standard deviation is 11.3. Alright, so we're going to go backwards, and we're still doing 90% confidence, but now we're assuming that the standard deviation is 11.3. 11.3, standard deviation 11.3. Confidence level 90%. And we want the width to be within 4, so that'd be a total of plus or minus 4 equals a width of 8. Click compute. Now the sample size is 22. Alright. So the question is there a big difference between those values? Okay, so compare the results from parts A and part B. So the result from part A is larger than the result from part B. The result from part B is likely to be better because it's based on more information. It uses a better estimate of the standard deviation because this estimate, this 22, was based on the value of the standard deviation estimated from the sample of 175 data points. And so the moral of the story is it's more accurate, and a lot of times it's more efficient. For example, we ended up using a smaller sample size if we base our future estimates and statistics on our previous measurements of data that we've already taken. So it's better to build on your existing data than to just start from a completely unknown assumption like the range rule of thumb. But if you don't have any prior information, then it's still fine if you want to do something like use the range rule of thumb to estimate the standard deviation. Alright. Now let's look at question number 7. So the way to estimate a confidence interval of this population standard deviation is based on, first of all, you open the data in StackCrunch. So click this data icon, then click open in StackCrunch. And then you will find the standard deviation of it. So click on Stats, Data, Stats, Summary Stats, Columns, Variable 1. And the only thing we really need right now is just the standard deviation, so click Compute. Alright, now the standard deviation is this number right there. Now I'm going to show you a formula real quick for estimating let me type it over here. Okay, so there's a formula for estimating something called variance. So if you take sample variance times the degrees of freedom, which equals n minus 1, and you divide that by the chi-square critical value, then you'll get, now it said parse error because I wasn't typing an actual equation in, I was just typing words, but I was just making a note. So if you take the sample variance, which, that number that I just copied actually is right here, so that's the one that I really want actually. So variance, the variance. So if I take the sample variance, which is 25.78, times n minus 1, which n is 12, so n minus 1 is going to be 11, and I divide that by the chi-square critical value, then I'll get an estimate of the of the population variance. So let me do that real quick. So what is the chi-square critical value for a 90% confidence interval? Well, there's going to be two of them. One of them is the area at the top 5%. The other one is at the bottom 5%. So we're going to find the one first at the bottom 5%. So it's going to be 0.05. And so 0.05. Now that one, 11 degrees of freedom. So that number is 19.675. 19.675. So then I'll divide by 19.675. And then that number is the estimate of the variance. So I'm going to have to take the square root of that number in order to get the standard deviation. So that's one of the standard deviation values. That goes right there. Round it off to 1 decimal point. It'd be 0.8. Then we're going to do the same thing again. We're going to do this equation right here. So we're going to do this number, which is the sample variance, times n minus 1, which is 11. But this time we're going to divide by the right side of the graph, the right critical value, which is the 0.95. Because 0.95, remember, represents the 5% at the right side of the graph. So go down to 0.95, and then look for 11 degrees of freedom. That's 4.575. So 4.575. Then we get 62. So that's this variance. So I'm going to take the square root of the variance to get the standard deviation, and I get that number. Okay, then I'm going to put that in. Then I'm going to round that off to 7.9. Now before I stop and go on, I'm going to also show you there is a way of doing this with the computer as well, without having to do all those formulas by hand. So what you do is you click on, go back to StatCrunch, and you click on Stats, and then you click on Variance Stats. And you click on one sample, and then you click on, one sample with sample size right there. Okay, so now here's what you do. Now you are constructing a 90% confidence interval. So you're going to use 90% like this, and then you enter the sample variance. So the sample variance, it's back in this window right here. So you're still going to need that sample variance of 25.78. So enter that number, the sample variance of that. Then you're going to enter the sample size. Oh, actually, just a second. Just a second. You don't actually have to do all of that. I was making it too hard. Okay, so just all you really need to do is just this. Let me close this window. Just click on the data, click Open in StatCrunch, and then just click Stats, Variance Stats. Since we have the data already, we don't have to reuse the numbers from the previous set of data. We can just open the data in StatCrunch again and click One Sample with Data. And then you just click Confidence Interval for that. Sigma squared means the variance. And then you do 90% confidence interval, means you click on this dot and then you change this to 0.90 to represent 90%. Then you click Compute. Whoops, sorry. And you have to select a column of the data. Click on that. Then you click Compute. And then you get those two numbers. Now, one thing you do still have to do, the computer can't do this for you for some reason. It'll only construct an interval for the variance, because that formula that I taught you, that is the formula the computer is using, and that formula only calculates an interval for the variance. So at the end, remember, you have to take the square root of variance in order to find standard deviation. So you still have to take this number and do the square root of that, and you'll get that. Remember, we got 3.8, and then you have to take the square root of this number, and then you get 7.87, which rounds off to 7.9. That's how we got the 7.9. So the quick and fast way of doing this question on your test is to just simply open the data in StatCrunch and then click on Stats, Variance Stats, One Sample with Data, and then just do a confidence interval. Set the confidence level to the same confidence level that's given to you in your problem. Then click Compute, and then you just take the square root of the two answers that you have. Okay, so does this confidence interval describe the standard deviation for all times during the week? Well, that's kind of confusing, but it's talking about the time of day. So all these samples were only obtained at 3:30 p.m. So, no, the confidence interval does not describe it at all times. It only describes them at 3:30 on a weekday. Okay, so perfect. Now question number 8. Okay, so you want to be 95% confident. So that would be the top box, 95% confident that the standard deviation is within 30%, within 30. So you want to be 95% that it's within 30. So you'll look right here, this number, 21. So the sample size is 21. Is that a practical sample size? I would say yes, 21 isn't too big. So I would say yes, because the sample, so is it practical? Is the sample size practical? Yes, because the sample size is small enough to be practical for most applications. Now, it says most, so obviously there's some applications when 21 would not be practical. Like if you had to land on the moon 21 times, that would be not practical. But in most cases, the sample size of 21, at least in most easy cases, the sample size of 21 is small enough to be practical. So that's all for that one. All right, so now here's a bunch of samples. Now you might have asked yourself, well, instead of needing to learn statistics, why can't you just throw all the numbers into a hat and then just pull them out again and again and again until you know which outcomes are the most likely to happen? And the truth is, you can actually do that if you have enough time. So what if you had a sample like these numbers right here? So look at those numbers right there. What if you had a sample of numbers and you wanted to find a 90% confidence interval of the mean of those numbers? Well, guess what you could do? you could throw all the numbers in a hat and then draw out the numbers again and again with replacement even, because you'd have to eventually replace them. You throw them into a hat, draw them out with a replacement again and again until you've done 200 samples of them, and then you find the percentiles of all 200 of those samples, so that you figure out the 90% confidence interval from that. So I'll show you. Obviously we're not going to use a hat. So what you do is you just click on the table of bootstrap samples. Now my internet's a little bit slow, so we'll just have to wait a second. Okay, so click on this sample and then click open in StatCrunch. Now this is going to be kind of fun. So we have 200 samples. All of these samples represent, if you took the original numbers and you threw them all in a hat and then you randomly took them out with replacement again and again and again until you got a sample, then another sample, then another sample. So what we're going to do, we're going to click on Stats, Summary Stats, Columns. We're going to click on those columns. Now do this. Do either Control A or Command A to select them all. So we're going to select all the columns and then go down here and only click on Mean. That's it, just only on Mean, nothing else. And then click on Compute. So, I forgot something, just a second. Click on the options, click on Edit. You have to click one more button. You have to click Store in the Data Table. So what happens now is you can close this box, and now notice that there is a new column of data. There's a column right here at the end of your other columns. That's the actually wait. For some reason, oh there it is. So sample 2 went first. I'm not sure why that happened. So sample 2, then sample 1, then sample 3, 4, 5, and it took the mean of all the samples. Now what you need to do next is click on Stats again, click on Summary Stats, click on Columns. Now you're going to scroll to the end, click on that main column right there, the main one, the very last one, and then let's look back at the problem. It wanted us to find a 90% confidence interval of the mean of the sample. So what would happen is the 90% confidence interval, that's the one that goes from the 5th percentile to the 95th percentile. So you're just going to type 5, 95 into this box. 5, 95, then click Compute. And then the 5th percentile is 233.3333. So put that in, run it off to 0.3. And then your 95th percentile is 247.6. So you put that in as well. And then there you go. You've estimated you've made a 90% confidence interval of the mean just by taking 200 samples and then finding the bottom 5th percent of all those samples and the top 95th percent of all those samples, and then you have the estimate. Now the computer did lots and lots of work to generate all of those samples. So what's the way that you normally do it? Well, normally when you do statistics, the way you're supposed to do it is the more efficient way. You just use the appropriate distribution. So the estimates of a mean are done by using a t-distribution. That's the normal way and the easier and more efficient way of doing them. So we're going to click on the copy of the table, click Open in StatCrunch, and then we're just going to click on Stats, T-Stats, one sample with data. We're just going to take that one column of data, and we're just going to do a confidence interval for the mean. The level is going to be 90%. Then we're going to click Compute. And then we get the lower limit. And then we get the upper limit. Round it off to one decimal place, so 0.5 and 0.5. Now you don't get exactly the same thing, but you get really close though. So compare those results. The result from the bootstrap method is reasonably close to the result found using technology. So the answer to your question is yes. If you wanted to, you could just throw all numbers into a hat and then pull them out millions of times to try to estimate the number of times that what you wanted to find out would actually happen, and then you could create things like a confidence interval based on that, based on all of those 200 random samples. But it's easier just to use one sample and then use the distribution that fits that sample. All right, so then that's all. And those are your notes for your Chapter 7 test.